Okay, so after this, we will go to the first topic, our syntax basics. So Python is heavily based on indentation. And if we want to do like the syntax, it's just defining the different coding blocks by indent over here. So if we have one indent over here, it indicates the print I is inside of the for loop. So it's not like C++, which use a lot of like braces for multiple lines under the same loop. And we can see an example over here. So right now this should work. And if I put an additional index over here, it will just yell at me saying there are unexpected indent. So keep in mind, indent is pretty crucial and also useful in Python. All right, so we can start introducing Python by variables. So in naming of the variables in Python can contain both alphanumeric characters and also special character underscore. So there are some examples about some valid variable names and invalid variable names. So you can see that we can use underscore in the middle of the variable and also in front of the variable. But for our invalid variable names, we cannot start with a digit, or we cannot add hyphen or space or dots or at in the middle of the variable. Is there any questions? So there are some rules for making variables. So by convention, it is common to have the variable names that starts with lowercase letters and have class name beginning with a capital letter. And I will introduce more about the class names later, but actually you can do whatever you want. So if you're making a variable, you can use this kind of examples. You can use like a upper case letter to divide this into two words or underscore between them. And some keywords are reserved and cannot be used as variable names because they are served as inbuilt Python function. So for example, and continue break, if you are making a variable name by this, it will actually yell at you and ask you to change it to something else. So something fun is that Python is dynamically typed. So the type of the variable is determined at the runtime. It's not like C++, everything is determined at compile time, which means in C++ you have to declare the type of the variable at the beginning. But in Python, you don't have to declare the type of the variable when you create it. So here are some common variable types. For example, int for integer, float for floating point numbers, str for string, bool for boolean, complex, and also we have the user-defined classes. So if we want to use the equal operator, it's basically assigning a value into a variable. So for example, over here, we are assigning the string of hello world into X. So when we print X, it's basically printing out the string. And since Python is dynamically typed, as I mentioned, you can actually change the type of X without explicitly declaring it. So we can just assign 6 plus 1 into X and print X, it will become 7. And we can also assign a Boolean into X. So when we print not X, it's false. And we will also get to this operator later. And the print function we used here is to print something on the screen, or more technically known as a standard output. So it can also used for debugging purpose. And here is a quick practice for you guys. Do you guys know what would this line print? Feel free to speak up or type in the chat. Great, 7.0. So we can verify that over here. All right, so as I said before, you can change the type of X during the runtime. So it is pretty useful if you want to check the type of some variable using the type function. So over here, if we apply type X into the variable X, we can get the class string indicates that it's a string type. And over here, it's an int. Over here is a float. And if we assigning true into it, it's a Boolean. Is there any questions? Okay, because I didn't see any of the wrong answer earlier, so I guess you guys already knew a lot of coding stuff. So the reason of our previous practice was like in Python, if we have at least one operand that is float, it will treat the entire operation as a floating number and assign a floating number into the result. Okay, let me know if you have any questions. And otherwise we will, there is no set. Oh, okay. Okay, here is another practice for you guys. So create a variable X and assign it with a string holding your name, and then output the contents of X to the standard output. All right, great job. I think everyone got the point that if we want to assign a string, we need to add the quotation mark. So I actually made some mistake before by assigning it without the quotation mark. And this could be a common question that people might have. So what would this happen when we run it? It will just say name is not defined because Python does not recognize what type of the variable is this. And our answer is simply like that. And I think all of you got this. Okay. So our next topic is the arithmetic operators. So this is basically similar to a lot of the other coding language. You use plus for addition, minus for subtract, and this star for multiplication, and star star for power. Something that is a bit different is the division. So there are two types of division in Python. If you use 1/ is the true division. So one example is over here. It's basically printing out a floating point number, even if you are using the integer to perform that. And if we use 2/, it's a floor division. So it's a little bit like the integer division in C++. So if you have something like 5 divided by 2 over here, it will print out 2. It's running down to the integer. However, something is not the same as C++ is that if we use -5 over here, I believe C++ would actually round towards 0, while Python would round towards the negative infinity. So this line would actually print out -3 over here. Is there any questions? Yeah, it's much simpler.
How come it doesn't round up for that first one?
It doesn't round up for this.
Yeah, like wouldn't it? I thought it would have been 3.
Oh, so Python is typically just rounding down. It never rounds up. Correct me if I'm wrong. I think,
Okay, cool.
yeah.
Thank you.
Mhm. Yeah, because the way I remember it is like Python only perform the round down because even if it's negative, it's rounding towards negative infinity. But I believe C++ would actually print out like a 2 for you. I mean like -2. Okay. So here is a quick note on the increment operator shorthand. Okay. So a Python has a common idiom that is not necessary, but it's frequently used and pretty useful. So if we wanna use x equals to x plus 1, the shorthand can be x plus equals to 1. And similarly, we can have x plus equals to y, which is adds y into the value of x, and x times equal y is multiplies x by the value of y, etc. So we can have a pretty short practice over here. How would you add 3 to the variable x in one line and then divide it by 4 in another line using shorthand notation? All right, great job, guys. So all of us got the correct answer. So let's move on to Boolean operators. So Boolean operators are useful when making conditional statements, and we will talk about the conditionals later. So right now, something for Python syntax is and or not, just the word and or not. So it's the same as the gate, like not gate, and or gate in circuit lessons. And this is like pretty straightforward. And you guys can just stop me if you have any questions. And also for comparison operators, it's also mostly similar to the other language. So greater than, less than, greater or equal to, less or equal to. And is equal to indicates like two equal sign. So here is an example over here. I think we would have the same one on my notebook. Okay. So we indicate integer a as 3 and float b as 5.0 and int c as 5. So if we compare int a and float b, it will actually print out. So we can know that float and integer can be compared. And if we compare float b with integer c, it's also printing out the result. So we can know that the same value in floating point numbers and integer format will match. However, this is a sign we need to pay attention to. So if we use float b is int c, we can see that the result does not print out. So we can see that b and c are equal, but they are not the same object. I can probably explain more about the object. So Python is basically an object-oriented language. So if we assign 5.0 and 5 to different variables, if we compare them, they are equal in value, but they are not the same object. So this keyword is it's actually trying to compare if the two variables are referring to the same object. So we can see it's definitely not the same, so we're not going to this branch. Is there any questions? Semicolons are not necessary on this language. Yes, it's not. I mean, no, it's not necessary. Okay, I will actually make a super short practice over here, and we will like assign different stuff like 8.0, 0, 0, 0, and 8. And you guys can tell me if this is true. Whoops, let me just copy the same thing. So question, so if float B and int C were both 5, would the final line be printed? This is a pretty great question. So technically it shouldn't, but in Python, a small integers are cached. So we cannot really know if it's gonna print out or not. Let me actually try it over here. It shouldn't, but we don't know because it's a small integer and they're always cached. Let's see. Yeah, it's printing out. So they're referring to the same cached object. Does that answer your question? Yeah. Okay, nice. I just finished my own practice, but let's just move on. Okay. So next, this fancy slide is imported from my CS131 professor, Karen Natchenberg, and I want to give the credit to him. So let's start with string. And we can have a lot of fancy animation over here. So note that Python is a zero-based indexing system. So the first characters in either a string or list or tuple is just 0, 0. So the second element is actually 0, 1 and counting towards. And there are a really simple way to extract or slice the string. So first of all, to extract a substring of length 1 from slot A, we can simply use string A. So can anyone tell me what would this line print? Great job. So it is actually printing out this index. So it's index 6, which is T. After that, if we want to slice a substring from slots A to B, we can use string from A colon B. Note that this is including A and excluding B. So can anyone tell me what would this line print? Nice, it's actually printing out CL. So it's printing out index 1, index 2, and excluding 3. So basically CL. After that, if we want to slice from 0 to B, we can just eliminate the number before the colon. So we can use string, bracket, and colon B over here. And can someone tell me what would this print? Nice, it is indeed UCLA from 0 to 3, excluding 4. And we can also do the same thing if we want to print a slot from A to the end. So we can just eliminate the character after the colon or digit after the colon. So we can just write string A colon. So what would this line print in this case? Yep, so it's from S towards the end of the string, sum. All right, and after that, we can also use the negative indexes for our strings. So we can use string negative A to negative B. This is still including negative A excluding negative B. So can someone tell me what would this print? Great job. It's over here. So I saw fewer people answering this, so let me try to declare that. If we want to put -1 as the index over here, it will basically print out the exclamation mark. So excluding -1 will give you OME over here. So it's -4 till technically -2. All right, is there any questions? Can you re-explain how the last two elements examples work? Yes. So for truth 21 colon without anything after the colon, it's from the index 21 towards the end of the string. So 21 is basically start from S and it will print out some and also the exclamation mark. And the last one, if we want to include, so for a -1 indicates the last elements in the true string. So over here, we can see if we want to print out this, it is the last element. So -1 is the last element because we don't have a -0, right? And our 0 index is actually this U at the front. So -1 is the last element in the string. And if we print out -4, it is this O over here. So we can see that this is -1, E is -2, M is -3, and O is -4. So it's counting like that. Yeah. So if we print out this, it's still including the -4, excluding the -1, and we will get the O over here. Is there a benefit to using negative numbers for your index versus positive numbers? There is definitely a benefit. So if we have a very large list or like the string, and we don't really know what's the last characters, but we want it. So we can just use the -1 or like -2. So that's when negative indexing are pretty useful. Does that answer your question? Okay, nice. No problem. Okay. And let's move on. So here are some methods to work with strings. And you don't actually have to memorize all of this, but I'm listing them for a reference. You can always search it up if you want to use it or just, yeah, look it up or ask ChatGPT, I don't know. But for length, it actually returns the length of the string. And we can see an example over here if we define our string as hello world. And when we print out the length of the S, it's printing out 13. And a quick question, what is the last character's index? in this case. Valve, yes, because we are starting from zero index. And I saw a question over here. I believe it's not valid, but we can try it. I'm not sure though. That's the reason we have this over here. And we will use -1 and -4. And let's try it. So it's not printing anything else over here. So it means we can only use it in this order. Does that make sense? Okay, nice. All right. And these two methods are also a very common method to convert all the characters in the string to either uppercase or lower cases. Okay, thank you, Ryan. And another examples are find and replace. I think I have the find over here first. So if you want to tell what index is the character or element in the string, we can use the find. And it will simply returns the lowest index of the substring if it's found in the string. If it's not found, I believe it will print out -1. So over here, we have the hello world. And if we want to find the world, it will actually print out the index of this W. So we have this over here. And we can see that I tried two different kinds and they can print out the same thing. So it's basically printing out the first element in your substrings. Is there any questions? If not, we can move on to split and join. Oh, did I skip replace? Okay, so replace is a method to replace the occurrences of a specified substring with another substring. So if we want to replace the world with Python, like we don't want hello world anymore, we want hello Python, we can just use the replace. So the first parameter is the substring that from the original string, and this one, the second parameter is the one you actually want to replace. So after that, if we print it, it becomes hello Python. Okay, so we have also split and join. Split will actually split a string into a list of substrings based on a delimiter. So over here, we specify the delimiter as the comma and space. So it will print out a list splitting it into two elements, which is hello and world. So the comma and string in the middle is disappeared. And if we want to join a list, we can have the parts as a list of substrings, and then we can specify the string we want to join them and use that to join the substrings. So this will print out hello Python, which is coming from this part, and then the comma and space, and then this part. Is there any questions? Okay, if not, we can move on to the practice. So create a string by s equals to hello world. How do you print out D, uppercase D? All right. I saw some answers over here, and we can actually try something out because I believe this is my answer, and I believe if you want to call the method, it's actually using a dot and then the method name to call it. But I'm not sure if you can directly call that. I think you might cannot. We can try it though. So we have this over here, and we will just print out. Let me copy one like upper S bracket -2, and yeah, it wouldn't let you print. Okay, so it will say that upper is not defined. So in Python, upper is actually a method for string. So with this method of calling, it's actually specifying we are calling a method from a variable that is string. So this is the way we're calling it. Correct me if I'm wrong, Ryan. Okay. We can also try something else because I believe um S12 should also work. Oops. Oh, it's not printing yet. It's not copying from my desktop. So number 12 is actually an exclamation point. And this is why negative indexing are pretty useful. So if you have a longer string, it's pretty easy to mess up when you count it from left to right. So if we want to do the D, we can just use -2 instead of counting from the beginning. As upper -2. So the other answer as upper -2, I believe it wouldn't work as well. The way I'm calling it is usually without any parameters over here. So if we put -2 over here, let's try it. Yeah, it will give out an error. So this method is usually used without a parameter. So over here, you can see the answer. If you want to convert the whole string into uppercases first, you can do s.upper first, and then retrieve the -2 from the string. Or you can just get the -2 from the string, so get the D, and convert it to the upper. Is there any questions on this? Did I explain anything wrong, or is it good enough to understand how it's working? For the first way, does it make the D in Hello World capital, or is it just a copy? I believe it's just a copy. Yeah, because actually strings in Python is immutable, which means you cannot actually change one of the element or some of the element to something else. And if you are trying to add something like concatenate or like multiply or like make some modification, it's actually referring to another object. So you can't really change one of the element in the string. Does that make sense? Okay. If I print S again, will everything be capitalized now? We can try. I think so. Do you mean like from this line or the other line? The second. Nice, we can try it. Oops. So we are just printing out S. Whoops, it's not. Okay. That means it's not. Oh wait, is it upper negative 2? Yeah, I think the reason is that we are not assigning this into S, I believe. If we assign this to S dot upper, and this is actually, if we do this, it will print out hello world all capital. So basically, in this parenthesis, it is just referring a temporary object, temporary variable into the object of that result, but it's not actually changing the S. The way you want to change S, technically referring X to another object is to assign it with the equal sign. Does that make sense? Okay. All right. Is there any other questions? Okay. However, I think before we put this one here, if we don't use the -2, it's also gonna print out the same capitalized strings. So I hope that makes sense. All right. Moving to the next. So this is the tuple. I also hear people calling it tuple. I think both way work. And I'll just use tuple because my professor used that. I'm not sure if it's like technically super correct, but yeah. So a tuple in Python is an ordered, immutable collection of items. So we can define a tuple with parentheses. So these are some modification you can apply on tuples. So concatenation, you can concatenate two or more tuples using the plus operator. So for example, we have 1, 2, 3, 4, 5, 6. So if we add them together, the output would be 1, 2, 3, 4, 5, 6. And after that, we have repetition. So you can repeat a tuple using the start operator. So if we do have the example 1, 2, 3 over here, and we use the example start 2, it will print out 1, 2, 3, 1, 2, 3, repeating 2 times. And also you can check if an item is in the tuple using the in keyword. So sorry, if we want to check if 2 is in the tuple, this is the variable we are assigning to, and this variable will print out true, like if we print out this variable. And if we want to check if 4 is in the tuple, this variable will be assigned with false because 4 is not in 1 or 2 or 3. Is there any questions on this?
Is the word tuples a function, or they're just using it as an example?
Tuple is actually a variable type, I think, like a data type in Python. So it's like a list, or yeah, it's just a special variable type because list is mutable and tuple is immutable. And the reason we want to use tuple is that for me, at least, I like to use the unpacking tuples. So there is a technique or like a useful way to unpack a tuple into individual variables. So if we have like a tuple as 1, 2.0, and 3, and over here we are doing like a comma b comma c equals to the tuple. And when we print it, it will be assigned with each element in the tuple. Does that make sense?
Yeah, kind of. Yeah.
Yeah, and you can
Okay.
also see that it is a data type over here, because if we want to print out the type of that of this variable, it will print out tuple. They are, so a tuple is a type of class. I think for all of the variable types in Python, if you use the type method, they are all gonna print out a class over here. So actually it's like object oriented, and I think you can understand it as a variable type, but they are basically classes, I think. Correct me if I'm wrong, Ryan. Okay, so if we are going back to a very previous example, we can see it over here. So the string is also in class string, and integer is in class int, and float is in class float, and boolean is in class bool. So this is the way that type X works. Does that kind of answer your question? I would understand it as like a built-in class. So I think that would, I think it's a built-in class. Yes, built-in class. I hope I'm not wrong, but correct me if I'm wrong, because I'm also like pretty new to Python as well. I'm just trying to, yeah. Okay. I think we already go over this. All right. Is there any questions about unpacking tuples? Okay, if not, we will move to dictionaries. So dictionary is another data type in Python, and it's basically a collection of key value pairs. So over here, we can define a dictionary by the braces, and before the colon is the key, and after the colon, this is the value. And we can separate the value key pairs by the comma. So dictionaries are unordered, so it's not like list or tuples. It does not contain any order for their elements. And also dictionary is mutable, so it's not the same as tuple, I think. So which means you can actually change the value or add new key value pairs or remove key value pairs after the dictionary has been created. So over here, this is the way we want to access the value. So we can just use the variable name user as we declared over here. And this is the key in the dictionary, and it will print out the value after the name key. So this will print out Alice. And we can also see here, the type of user is a dictionary. And the way to add a new key value pair is to just use this variable and put your new key in the bracket and your new value over here, and it will be added into your key value dictionaries. And also the way if you want to update an existing value, you can just put the existing key over here. and put your new value over here. So when we print this out, we can see the age is already updated. And to remove it, you can use delete, DEL over here. And you will need a key to access or actually index the key value pair. And if you delete the city, it will also delete the pair. So we will not see the city anymore over here, but we will have the new key value pair we added over here. And dictionaries are indexed by keys, which means each value is accessed by an unique key. So it also requires the keys are unique. And can you have keys of different types in the same dictionary? Yes, I believe so. You can have, I believe, immutable keys. I mean, immutable types for your keys. But they have to be unique. Is there any other questions? We can actually use this time to try it out because I didn't really try it yet with probably let's do an integer as the key and then something else like floating number to be the value, and we can print it out and we can see it's over here. So we can definitely have different types of key and value in the same directory. I mean dictionary, sorry. Does that answer your question? Okay, nice. Is there any other questions? Okay, if not, we will be moving on. So finally, we are going to lists. So lists are ordered mutable collections of items. So it is initialized by the square bracket over here. So remember that for tuple, we have parentheses, and for dictionary, we have braces. And then for the list, we have the bracket. Sorry. So the list can contain elements of different types and support various operations and method. So it's very common use in Python. And some common operations include accessing, adding, removing element, and sorting and reversing. So sorting and reversing is just a sort method and reverse method. And we will get to know some add and removing element later. So note that it's denoted by the bracket. And here is an example of accessing elements. So it's a little bit like strings. We can also use the index. And remember, we are zero-based indexing system. So the 0 is the first element, which is the 10 over here. And we can also use the negative indexing system, which is -1 refers to 50 as the last element. So somehow like string, we can also slice a list. So if we want to have a sublist, we can assign it with the original list with the index from 1 to 4. And remember, including 1, excluding 4. So our sublist would be from index 1, which is 20, index 2, 30, index 3, 40, and excluding index 4, 50. Is there any questions? So the actual list doesn't change or not affected by the sublist, right? Yes. So I believe if you are talking about this original one, it's not changed. So this is basically, yeah, just assigning this part into the new variable. Can you explain the difference between list and tuple again? Yeah, for sure. So list over here, you can see that it's ordered mutable collection of items. However, for the tuples, it is ordered immutable collections. So when we create a tuple, you cannot change one of the element in the tuple anymore. So if you are doing some concatenation or repetition, it's actually referring the new variable into a new object, into a different object. So for list, you can access through index and add or remove the elements in the list, and I believe the variable will still refer to the same object, but for tuple, it cannot. Does that answer your question? Okay, nice. Let me know if you have any other questions. I know this is like confusing and a lot at the beginning. Okay, so let's see some method how we can add the elements to a list. So first of all, we can use append to add a single element to the end of the list. So this append is adding only one element. And if you can see the example over here, we have the original example as 10, 20, 30, 40, 50, and we can append by 60 as the parameter, and our original list will become 10, 20, 30, 40, 50, and 60. So it's added at the end. And if you want to add multiple elements, we can use extend. It's also adding it to the end of the list. Okay. Okay, never mind. So by using the extend method, we can add for example, 2 element over here. So we're adding 70 and 80 over here, and our original list will become this. And if you want to add some elements into a specific position, and we can use insert. So the first parameter of insert is the index where you want to insert the value. And the second parameter is the value you wanted to insert. So over here, if you want to see the example, we're adding 15 at index 1. And 10 is basically index 0, as we talked about. And it's adding it in the position of index 1. And all the other elements would move to the back for 1 space. Is there any questions? Yeah, and also notice that the way we're calling the functions, they're all followed by the variable name and a dot. And then if you want to pass the parameters, it's in the parentheses. Okay, so this is the ways we remove the element from the list. So first of all, this is actually not a method like the others. So it's actually, I think, a statement to remove the element if you know the index. So this is a block of code of the example. If we have the example list over here, and we know that we want to delete the element at the index 2, which is the value 20, because this is 0. And we can just use this statement. So when we're using delete, it's not anymore like dot delete or something. And it's mostly like this statement, delete and followed by a space and the specified variable name and also the index. So if we print this out, we can see we deleted the 20 over here. It is pretty useful when you know the index, or if you want to delete multiple elements in the same example list. So you can also use the slicing method over here, like 2: something else. And the next one is the remove method. So the remove method removes the first occurrence of a specified value. So you can use this when you don't know the index. For example, we have the example list over here as this. We don't know where the 30 is at, but we know that we want to remove 30. So we can just use the remove method and pass the 30 into it, and it will remove the 30 out from the list. Is there any questions about this? So I do have an example over here by removing the first occurrence. Yeah, over here. If we have, for example, 2 occurrences of 30 in the same list, and if we're removing 30, and it will print out the list without the first occurrence of the 30. It's not removing both of them, and it will still leave the second 30 in the list, which is over here. Is there any questions about this? All right, no questions. And the other way is if we want to remove and returns the element oh, okay. So for pop method, it's actually used for removing an element, and at the same time, if you want to retrieve the element or save the element to some space. So if we have the original list over here, and if we want to save the element we just removed, we can use the last element over here and assign it with the pop method. So by default, it will remove the last method if we don't pass any parameters in it. But if you do have the specified position, you can pass the index into it. And this way can remove the 80 and also save the 80 into the last element variable, which is defined over here. And last but not least, clear will basically remove all the element, which is pretty convenient and clean. Is there any questions? Okay, here is the practice. So create a list by my list equals to 1, 2, 3, 5. And now I want you guys to add 4 between 3 and 5, and then removes the element 2 and 3. So the output would be 1, 4, and 5. Yeah, don't forget to use shift and return together to start a new line. There is no one sending out messages.
Do you have the slides?
Yeah.
So I
I
can look at the dot app there.
Mhm. I can share the link into the chat again.
Yeah,
And
that'd be great. Thank you.
I got it, Jalen.
nice, thank you.
Can you go back to the question?
Yeah.
Quick question: is a way to remove elements 2 and 3 in one line of code, or is that just like it's not something you could do?
It doesn't matter. You can remove it in one line or two lines, as long as it's removed.
Gotcha.
All right, I've seen a lot of correct answers. So the answer here would be declaring my list and insert 3, 4. So basically inserting 4 into index 3, which is 0, 1, 2, 3. 4 here and 5 over here. And if you want to use my one line, you can just use delete my list from 1, 2, 3, I think. So it is deleting from the index 1 and index 2. It is deleting the 2 and 3 in this case. And remember that we will use 3 over here because it's excluded, and print out my list. So we can try it out over here. This is the way we're using one line. And if they run it, it will print out 1, 4, and 5. So I saw a lot of people have 2 over here. And please remember it is excluded. So we will count 3 over here in case we want to delete the index 1 and 2, which is the 2 and 3 in the list. So if we are using 2 lines, we can use the remove. So remove can basically only take one parameter at the same time. So I have another error over here trying to use like different parameters into the remove, and it will yell at me saying it only takes exactly one argument. So this way would take you 2 lines, but it also works and it's straightforward. So in this case, we're just putting the value over here in the parentheses. And is there any questions? Can you use a comma in the remove instead of making 2 lines? Not really. I have it over here and I got the type error. It says list remove takes exactly one argument. So I'm giving it 2 and I'm getting an error from it. Does that answer your question? Yep, okay. Is there any other questions? All right, if no questions, we are about to take a 10 minutes break. Is that good for you guys? That's a lot of information to digest. So yeah, let's take a 10 minutes break and come back at 7:36. All right, welcome back. And something I want to specify, if you remember, so the student asked me, what if we assign the same value to the same, different variables and print out if they are the same? So during that time, I said they were supposed to not printing out true, but they were because the smaller numbers are cached in Python. So I basically made a small example over here, and we can see if we assign 10 to different variables and print it, it will actually consider them as the same object. But if I'm using like a billion, it will print out false. So they are actually referring to the different objects. Does that make sense? Or does anyone have any questions about that? Okay, if not, we will get back to our, oops, where is my, oh, let me actually put this over here. Okay, we will get back to our lecture today. So right now, let's start for loops. So the for loop is pretty much the same as a lot of different other languages. So it's essentially saying for all elements in the sequence, do something. So here is an example of a for loop. So in Python, we can use the in to traverse from the list. So if we have for I in animals, and animals are a predefined list, and it will print out this. So it's basically printing out from the first element to the last one. So the command underneath the list cycles through each entry in the animal list and print out the animal names. And another way to use a for loop is to use the range function. So the range function generates a list of numbers, which is generally used for iterate over within for loops. So we can see the example over here and also over here. The range function has two sets of parameters to follow. So you can either call it with only one parameter over here. So the only one single parameter is indicating the stop number of integers. So we have an example over here. If we are passing 5 into the range, and print each element, we are basically getting from 0 to 4. So because Python is zero-based indexing, we have 0 as our first element. And when we generate 5 numbers, it's from 0 to 4, not including 5. So another way to call range is to pass two different parameters into the range function. Am I recording? Yeah. So we have the first element as the starting point and the second as the stopping number. And if we print out over here, it is from 3 to basically 6, excluding the 7. And the third way to call it is having 3 parameters, which are start, stop, and step. So the step is the difference between each number in the sequence. So over here, we can see that if we're calling it with 4, 10, and 2, so 4 is our starting point and 10 is our stopping point. 2 is the steps. So we are basically having a sequence from 4 with the difference of 2 to 6 and 8 and stop before 10. Is there any questions? All right, if not, here are some quick notes for the range function. So as I said, all the parameters must be integers and the parameters can be positive or negative. And also the range function is zero indexed. So it is starting from 0, excluding the last stopping point. Another function that is commonly used in for loops is break. So break is to terminate a loop. And if you have the break statement, it will break out from the innermost closing for or while loop. So for example, over here, we have the for I in range 1 to 5. And if we run this, it will basically print out 1 and 2. So it will stop the loop when I equals to 3, which would never loop anything else again. Also, over here, it is the same one as the one I have it over here. So the break is only breaking or terminating the innermost loop. So in this case, if we have a nested loop, it will only break this block. So you can see it from the result. It is stopping when j is equals to 3 and it wouldn't print out the j equals to something over here. So the inner loop will always only print out j equals to 1 and then j equals 2. And it's not actually terminating the outer for loop, which is looping from 1 to 6 by the index I. So you can see it here. We can still loop through 1, 2, 3, 4, 5 over here. Is there any questions? Okay. Note that even if I have the parentheses over here, we don't have to put it over here. So we can just use the break keyword. Okay, and then this is the continue function. It serves a different kind of method for a loop. So if we are using continue, it's actually skipping the rest of the statement in the current loop block, but it will keep continue the same loop for the next iteration. So over here, for this example, if we run it, we can see when I equals to 3, we have the continue over here. So it will not go to the print over here. So if we see the result, we can see it's from 1 to skipping 3, going to 4 and 5. So the loop is not actually ended. It's just skipping this statement after this continue when I is equals to 3. Is there any questions? Okay. So while loop is pretty similar to all the other language as well. So it's essentially saying while this is true, do this. So the break and continue I talked about is used as the same way for loop, for while loop and for loop. So with these two different loops, when would you want to use for, or when would you want to use while loop? So basically in Python, you will use for loops more often, but there are a specific way to use one of other, like one over each other, one over the other. So if we have the determinate sites, which is we know how many times we want to how many times we want to iterate, or we are cycling through a list or a characters in the string, we can use for loops for that. However, if we don't know the number of times we want to iterate, and we only know like a condition when we want to stop it, we can use the while loop. Is there any questions about that? Okay, so let's start conditionals right now. There are three main conditional statement in Python, which are if, else, and elif. So pretty much the same as all the other language. If test a condition, if it's true, it will execute the block inside of if statement. And elif stand for else if. So it checks another condition if the previous if or elif was false. And last, else execute a block of code if none of the previous conditions are true. So for example, we have here, we're setting school night equals to true. And when we check if school night equals to true, it will simply just print out workshops. And if we set the school night equals to false, when we check the if statement, it is not true over here. So this line of statement is not being executed. And we will go to the else and print relax. So this is an example of if and elif. And we're setting school night equals to true and Jalen sleeping equals to false. What would this output? It's basically the condition of today. Workshop, correct. So we are going to this if statement and checking if this whole statement is true or false. So we're setting school night equals true, and not is the Boolean operator to negate the school night. And so this statement is false right now, and it will not go to the block of code over here. And after that, we will check the elif. And Jalen sleeping, obviously false. It's not going to this print statement, and it will finally go to the else statement and print out workshops. Okay. And finally, we're going to functions. So a function is a block of code which only runs when it is called. So they are usually useful if you have the operations that you need to be done repeatedly. For example, if you have some calculation or general action that you want a lot of variables to use. So the function in Python must be defined before it is called. And if you want to create a function, for example, that takes two inputs and you want it to do something and return the result of it, it will look something like this. So we have the def over here indicates define. We define the function with the function name, the two parameters passing it, and we're asking it to do something and return something. And note that we have the indentation over here. And this is a quick example of defining a function. So we're basically defining a function called mean over here, and we are parsing in two different parameters, which are A and B, and we're returning the result. So when we call it, it's printing out the result. And as I specified over here, the function must be defined before it is called. So if we're defining the function average over here, the Python IDE or compiler would not recognize it and give the name AVE is not defined. That error. Is there any questions? If not, we have a pretty simple practice for you guys. So I know we built a NAND gate in our circuit workshop. So right now I want you guys to use software to solve this. So you are basically creating a function called NAND that takes two parameters, A and B, and return a Boolean as like a NAND gate. So we will see it's printing out true if any one of A and B is true or not, like A and B are both false, and printing out false if they are both true. So try to solve this out and send it in the chat. Remember to use shift and return for a new line. And also remember to use the correct indentation. All right, I got a lot of correct answers. And the answer to this practice are like this, but these are not the only correct ways. So we can either just return not A and B, or we can have the different conditional branches for if and else. Yeah, so note that in Python, we are using the word and, or, and not to negate something or operate the Boolean operator. So over here, we can check this out or check this out. So those both work. Is there any questions about this? Just do not be afraid to make any mistakes, because I know a lot of you knew C++ better, and I sometimes also mess it up. So yeah, just remember in Python, we're using that simple words for Boolean operators. Okay, if no questions, we will dive into something fun. So this is the import. So a great thing about Python is that we have a lot of libraries that are already public, and we can just use the functions or method in the library without completely writing something from scratch. So these are the 5 ways to import something. And first of all, we can just import a module name. So this line of code will just import the entire module. And if we want to call it, we will use module name dot item to call the function or method inside of the module. So over here, I have an example. If we want to import math and call the square root method inside of math, by importing it this way, when we use it, we will just call the math over here and use a dot and then the item name. So it will perform the square root calculation for 16, and that's the result. The second way is from a module name, import item 1, item 2, etc. So this way is importing the specific items from the module. By this way, if you want to call it, you do not have to specify the module name over here, because you're just importing the items. So you can just use the item name to call it. An example over here could be from math, I am importing square root and pi. So we can just use it directly over here. When we print square root 16, it's printing out 4. And if we print out pi, it's printing out the value of pi. After that, we have another method, which is from the module name, import the star. So this is basically indicating we are importing all of the items from the module. So similar to the previous one, if we want to use the item, we can just call the item. However, we want to use it with caution, because this is importing a lot of different items or method in the module. So it might pollute your code by overriding the method you created by your own. So for the example, it is pretty similar to the previous one, calling it without the module name. After that, we have import module name as alias. So this way is basically importing the module name with an alias name. So for example, you don't like this module name, you can specify something else, and when you call it, you can use the alias you created and call the items inside. For example, import numpy as np. And if we want to use it, we can just use np.array or .anything. And the last one, you can also import the items as alias. So it's similar to the previous second and third one. You are importing the item as alias from a module name. So when you call it, you don't have to specify the module name, and you just need to call it as the alias name. So over here in this example, we are importing the square root, but we don't like this name and we want something longer. So we're having the alias as square_root. And we can just directly use this alias, and it's basically calling this function from math module. So I got a question here. What's the difference between import module and import star? I thought for both everything is getting imported. So import module, it's importing the whole module, but import star, do you mean by this? Yes. So from module name import star, it's basically only importing all the items or method in the module. So we can have a lot of different method names over here. And you want to know, like, if you really want to do this, you really need to make sure that you know what's in the module and if the method names are the same or different from yours. So, because there might be a chance that, for example, here, I specified a function named sqrt myself, and I wanted to do something else. However, if we are importing everything from here, it's basically polluting your code. It makes Python not know like what kind of method you want to run, and it will kind of like overwrite your code, or your code will overwrite the square root in the original module. However, if you are importing only the module, you have to, like, if you want to use the square root in the module, you have to have the module name first and have a dot after it. So if you're calling square root itself, it's calling the one you define by yourself. But if you want to use the square root in the module, you will have to use the math.square root. Does that make sense? Okay, nice. Is there any other questions? Okay. So we'll check the time. Okay. So next, we will start something more complicated about Python, which is object-oriented programming. And I think this is what Sina really wanted me to do. And it is okay if you don't get it, but I will include this over here for your reference. So OOP in Python is a program diagram paradigm that uses the object and classes to organize code. So it makes the code more like modular, reusable, and easy to understand. So some key concept of the OOP is the classes and object. So classes are the blueprint for creating object. So class always defines a set of attributes, which is the variable that belongs to a class or an object, and also the method, which are the functions that belongs to a class. So object is an instance of the class. So it is a concrete entity based on the class blueprint. And we will have more example later. So classes, This is also the fancy slide that I steal from Karen Eschenberg. And we can learn about Python class and also the difference between Python and C++. So here is the class definition. You can see it over here. And this is how we instantiate and use the object of our class. So C1 is our object, and we are initialize it using the equal and calling the class name car and initialize by passing in 16. So note that, as I mentioned before, we always use like lower cases to start a variable and upper cases to start a class. You can actually do whatever you want, but this is a way that differentiate class with your variables. So here are some questions, and I'll give you some time to consider it, and you can either unmute and speak up for the answers or type it in the chat. Also, you can pretty much find the answers through this example over here. Anyone want to answer the second and third problems? Defined from parameters. Using the self as a setter. Self. First parameters. All right, I think it's time to reveal the answers. So I think the slides start with how is a method different from a normal Python function. So we can see it over here. In Python, the first parameter of each method must be a self. So it serves similarly as this in C++. However, in normal function, they have no self parameters. So that's the difference between the normal Python function and the method inside of the class. And for the second question, probably the first one, most of you are correct. So the constructor, it is always called init, which are setting 2 underscores before the init and 2 underscores after it. And after that, how do you, okay, so the constructor is called when you define a new object. So like this, when you call C1 equals to car 16, the init function is called over here. And in Python, there is no way to declare a class's member variables without assigning them. So this block of code is an example in C++, where you can just declare the variables without assigning them. However, in Python, we have to assign it with some value. So to create a member variable method, a member variable named foo, you can simply write self.foo equals to some value. So this is the example over here. We are creating the gas gallons variable by self.gasGallons equals to something. Is there any questions? There is public and private in Python, and we will get to that later. Any other questions? No problem. Okay. So right now, let's add more method. So we are having the same code as before, but we are defining a new method. So it is over here, and we are basically using this line as the body of the method. And now we can replace this line by calling the method over here. So right now there are some questions. So if I change get odometer over here, so basically deleting the self over here, the code wouldn't work. Why? Could anyone answer it? Either unmute or type in the chat.
Oh, because is self a constant? So like you're just using that constant like as a way to def like another variable. So like once you delete that once you delete that like that self constant variable, like it'll return the value. So I don't know if I said that correctly or not, but that's what I thought.
I don't know if I understand it correctly, but so we will get to the answer later. But yeah. Actually, let's get to the answer right now because I think this is kind of getting hard in Python. So if we delete the self over here or remove it, it is no longer accessible because it's referring to a non-existent local variable. So only if we use the self over here, it is referring to the variable that is defined in the class car. So if we delete it, the odometer will be somehow an undefined variable outside of the class. Yes, the self is kind of like this in C++. So it's no longer referring to the attributes or variables inside of the class if we delete the self. And how do you call a method from another method? So I briefly mentioned this earlier. We're using that self over here and calling it from here. So I think there is animation. So a method calls another method by using the self prefix. So this is the self, like a mandatory self, and then with the dot, we can call the method defined over here. So how do we indicate whether a method is public or private? Can you guys see the difference over here? So self is definitely something you always need to use in the method, but what's the reason? I am not actually sure about the reason. I think without using the self, so the interpreter cannot understand you're referring to inside of the class. and it will actually check like outside of the class scope, is there a variable defined by that name? And without the self, we didn't actually define or declare a variable like that, so it wouldn't actually work. And the odometer will be in non-existence. Does that answer your questions? Gas needed have a self next to it. Where is the gas needed? Oh, okay. Because this is the scope inside of the method we are defining. So the gas needed is only valid inside of this scope. So we are defining it over here. And it's basically defined if you do not refer self in it. Does that make sense? Yeah. Okay. So for the others, if we don't use the self odometer, it wouldn't be defined anywhere else. But over here, it is defined right before it, so we don't have to use the self. And I believe it's not even the attribute of the class. It's more like a temporary variable to store this value and assign it over here. So it's not one of the attributes. Okay. Is there any other questions? All right, let's get to the third questions over here. So how do we indicate whether a method is public or private? So notice that over here, we have 2 underscore before the update odometer. So if you prefix a method with 2 underscores, so this will make it private. And by default, the others are public. Does that make sense? Is there any questions or thoughts? So init is also private? Yes, it is. How about protected? Great question. I will actually get to this later, but for short, private starts with 1 underscore. Oh, sorry, protected start with 1 underscore. And the private start with 2 underscores. Does that answer your question? Okay. Any other questions? All right. Why does init ends with 2 underscores but update odometer doesn't? I think they serves as different usage in Python. So for I'm not sure if I have it in the following slides, but for short, this updating 2 underscores and trailing 2 underscores indicates this is like a special format that Python would use to link. I'm not sure if that's the correct word, but it's like linking it into some specified method. So for example, if we are using underscore underscore init underscore underscore, it's basically a constructor and it will run automatically when we declare the object. So it's calling the constructor over here. And another example is like underscore underscore str underscore underscore. So it's like string, and it will basically print out it's not like print out, but convert the class into a string. So if you are printing something in your code, for example, if you are printing C1 and you define a string over here, and whatever you want it to be printed out, you can define it over here. For example, you want to print out the name and then the gas. So you can just define it over here, and when you call like a print and C1 over here, it will automatically call the method that are starting from 2_ ending by 2_ and the string over here. So it's like, I believe it's called like magic function in Python. And it's basically like linking it into some built-in methods. Does that answer your questions? Okay, nice. All right. So here is an academic bot says, the definition of Python class is just a sequence of statements like a regular Python program. So basically you can include any legal Python code in your class definition. So you can like print and define some variables and also define some method and print. So that's it. And the reason we want to use classes and objects is that we want to have the encapsulation. So this is typically done by using the private and the protected, as I talked before. So over here, we can see that private use is used only within the class in which it is defined. And for protected, which is denoted by 1_, it is for internal uses within the classes and also its subclasses. So it should be not accessible from outside of the class. And this is the example over here to initialize or define a class named bank account. And we will have the constructor over here, and we're defining some method. So outside of the class, we can call the method by this. So using that variable name and also the method name, so we can easily call this because this is public by default. And if we want to print it, it's like the same thing. However, I believe balance, yeah. So over here we have the private variable balance, and it is not accessible over here. So when I run it, it will just print out. It has no attribute called balance because it starts with 2_. All right, let's talk about inheritance. So inheritance is a mechanism where a new class's inheritance the attributes and also the method from an existing class, which is also called the base class. So it promotes the code reusability and establish a relationship between classes. For example, we have a class named animal over here. So in our constructor, we are having the names, and also we define a method called speak. So over here, we have another dog class which inherits from the animal class. So this is the way how you inherit from a base class. You simply put it as a parameter into your new class of definition. So over here, you can overwrite the speak function. And if you initialize a variable using the dog class, it's basically printing out the method using the one in the class dog. So there is another fancy slide about inheritance. So here are some questions based on what I talked about earlier. Can you guys answer that? And I'll give you some time to either unmute or type in the chat. So first one, how does a derived class inherit from the base class? And how does a derived class method override a base class method? And the third one, how does a derived method call a base class method? Great job. Maybe take some time to check out the example at the left side so you can know the answer of the 3 questions. Yes. Super. Great. Anyone else want to answer, or anyone else have different point of view? All right, if not, I will start explaining. So over here, we can see this is how we show a derived class is inherited from the base class, which is pretty much correct in all of your answers. And after that, so the methods are virtual by default, so you can redefine any method in the derived class. So even if we have a talk method over here, we can just define the talk again and let it have some like different actions. And if we are calling it over here, it is basically using the new override method. And then a derived class method can call any base class method via the super prefix. And the super is over here, which is also in a lot of correct answers. All right. Yeah, so if you are having like different attribute and you're defining a new constructor over here, do not forget to have the derived constructor explicitly call the base class constructor. So this line over here is basically calling this constructor to assign the attribute from the base class. So in the case over here, we're assigning name to the attribute called name. Okay. And if you forget to call the base constructor, it will simply not be called. All right. And also when you call a method, Python would automatically figure out the right one for the object. So over here, we have the p.talk, and it will figure out P is actually a student, and it will use the talk inside of the student. Is there any questions? Okay. If not, hopefully we are going to our last topic today, which is polymorphism. So polymorphism allows objects of the different classes to be treated as objects of a common superclasses. So it can provide a way to perform a single action in different ways. For example, before, if you remember, I have a class named animal and also a class named dog. And I specify or override the speak function inside of the dog. And right now I'm defining another class called cat and also having another different override function called speak for the cat. So they're basically printing out different stuff. And we are creating a list using animals, and we have different elements, one as dog and one as cat. So when we loop inside of the animals and print out the animal.speak, Python will automatically figure out what speak function it should called and print out either the dog would say woof and the cat would say meow. Is there any questions about this? Okay, I believe you guys are tired. So if there is no questions, we will get to our final problem set today. So after we get all of the information and knowledge, I want you guys to create a library management system. So for this problem, you need to create a simple library management system in Python, and it should allow adding and removing books, checking out books to members, and returning books. So the system should also keep track of the availability of the book. So here is a very simple design, which is we have like 3 classes, book, member, and library, and they serve as different purpose. And those are the functionality I wanted you guys to have, which are add and remove books, add and remove members, check out and return books, list all the books and their availability status, and list all the members and the book they have checked out. So a pretty quick hint for the listing, you can basically use the underscore string underscore to print the entire class as a line of string. So when you print something, it will print exactly the way you defined in your method. So here are some implementation details. And if you guys want, you can read these details and work in breakout rooms as groups. How many people do you guys think would be a better option? Oh, I got a question over here. How does it figure out which one to use? So I think for Python, we have something called duck typing, I believe. So it will, during the runtime, it will check if the object is belong to any of the class. So it will perform what you want the object to do based on the type of the object. Also Python, because it's a runtime, yeah, it's a dynamically typed language, so everything is defined during the runtime and also checked during the runtime. So during the runtime, it can actually figure out which one to use. Does that answer your question? Yeah, okay. Is there any other questions, like last minute question before we get to the breakout rooms? Okay, if not, I will go ahead and create some breakout rooms. Yeah. All right. Please go ahead to your breakout rooms and talk with each other to see if you can solve the problem together.